We're looking at 8.1, ladies and gentlemen, about polygons. We're going to identify, name, and describe polygons and use the sum of their measures of the interior angles of a quadrilateral. A polygon is a plane figure that is formed by 3 or more segments called sides. Odell, you can't turn this in now. You can't turn this in late. It's formed by 3 or more segments called sides, such that no 2 sides with a common endpoint are collinear, and each side intersects exactly 2 other sides at one endpoint. Each endpoint of a side is a vertex of a polygon. A polygon is convex if no line that contains the side of the polygon contains a point in the interior of the polygon. A polygon that is not convex is called non-convex or concave. So, this is a convex polygon. This would be a concave polygon. See how one of the points is in the inside? Concave, caved in, versus convex. A polygon is equilateral if all its sides are congruent. A polygon is equal angular if all its interior angles are congruent. A polygon is regular if it's equilateral and equal angular. A diagonal of a polygon is a segment that joins 2 non-consecutive vertices. So these last 3 are really important. The sum of the measures of the interior angles of a quadrilateral. Quadrilateral means it has 4 sides, good. The interior angles of a quadrilateral are 360. So if you add up all the angles on the inside, it'll equal 360. What does it equal if you add up all the angles of a triangle? 180. So quadrilateral is twice as big. Color sum of the measures of the interior angles of a quadrilateral is 360. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360. Let's draw a picture of what that looks like. If I have, let's say, a pentagon. Okay? If I have exterior angles of all of these pentagons, it looks like this. Olivia, will you open the door for Zayla? So it looks like this, right? Those are all the exterior angles. So these angles right in here, if I added them all together, they would always equal 360. So if I have a convex polygon, all those exterior angles add up to be 360, no matter how many sides it has. Okay. State whether each figure is a polygon. If so, name it by the number of sides. If not, explain why. So this first one, is this a polygon or not a polygon? Yes, it's a polygon. So let's see, how many sides does it have? 1, 2, 3, 4, 5, 6, 7. So do you guys know what a 7-sided figure is called? It's a heptagon. Is the next one a polygon? No. Why? It has a curved side. What about the next one? Polygon or not a polygon? Polygon, so let's count the number of sides. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decagon. Okay. Now for example 2, we're going to state whether the polygon is convex or concave. First one, convex or concave? Concave. Next one? Next one? Last one. Something like it. All right, let's look at example 3. Okay. We are going to do the first one and the last one, and then I'm going to show you one more type of problem. Okay. David, you need to be with Mr. Baker's and finishing up the test. Hurry up, please. Okay, the interior angles of a quadrilateral add up to what? 360. 360. So that's 90 plus 87 plus 93 plus x. So that's 90 plus 87 plus 93. We're going to add this all together. We get 270. And then I'm going to subtract 270 from both sides. 90. why don't you try number 4 on your own? I'll give you a second. D, yes, the 4th one. Try D on your own. All right, so what did you do for D? Okay, so we set it equal to what? So 360 equals 90 plus 6x plus 5 plus 10x plus 5 plus 4x. I like lining it up like that because now I add all the x's down. 16, 17, 18, 19, 20. So I get 20x plus 100. Oops, I'm sorry if you forgot her x. 20x plus 100 equals 360. Subtract 100 from both sides. 260 equals 20x. Divide by 20. 1, 3, 9, 6, 20, 40, 60, 13. Okay, we've got 2 more problems I want to do. Okay, we're going to look at this one. The exterior angles of any polygon adds up to what? 360. So 360 equals 45 plus 40 plus 77. This one you had to add to your paper. Plus x plus 2x. Okay, so I'm going to get 3x equals 7, 8, 9, 10, 11, 12. Carry the 1. 8 and 8 is 16. Oops. That should be plus. Equals 360. I do want you to add it. So 360 minus 162 is 198, which equals 3x, and then we're going to divide that by 3. It equals 66. I just know the exterior angles add up to 360. So I added all these things up, and I got 3x plus 162. Subtract 162, divide by 3.
Wait, hold on.
Exterior angles equal 360.
Yeah, I get that.
So I said 45 plus 40 plus 77 equals 162. 2x plus x equals 3x. Okay, this is going to disappear in a second, and I want to do one more problem. Has it gone? It hasn't gone anywhere yet. Dana's right next to you with the stuff. You need to relax. Okay. It is going to disappear. It'll be okay. Okay, if I told you, we know that the interior angles, and you need to write this down in your vocab too, the interior angles of any polygon is n, the number of sides, minus 2 times 180. You need to write this down in your vocabulary. This is the interior angles of any polygon. Okay, so if I said something had 16 sides, where would you put the 16? N. So you'd say 16 minus 2 times 180. So 16 minus 2 is 14. 14 times 180 gives us 2,520. I just said if I had a polygon with 16 sides, so I just made up. Okay. So problems 3 through 10, you're going to have to do something like this. Okay. One other one might be, let's say I tell you the interior angles of some polygon is 720. How would you figure out how many sides it was? You'd say n minus 2 times 180. So you divide both sides by 180 and then add 2. And that would give you the number of sides. Okay. This is on the homework. This is numbers 7 through 10 are like this. 3 through 6 are like the previous one. 11 through 13, you're going to have to use this in combination with the interior angles, add up to these. 14, 15, and 16 are exterior angles. Some of them you're going to have to find the interior and the exterior angles. Regular means all the sides are the same, but remember it means all the angles are the same as well. Okay, get out your writing, please. Get out your writing, please. Diagonals are like this. So if I've got a pentagon, the diagonals are like this. Oops. This is a good question. This will be in your homework as well. Diagonals are like this. It's connecting vertices that are not next to each other. Okay. In some polygons, there's special things about diagonals. In this case, it might just ask you how many diagonal, if you have like a 6-sided figure, how many diagonals you are. You can just do it like this and then count them. Okay, you should have your writing out in front of